We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
The Apollo 11 mission is a historical landmark. It represents so much to so many people. It has become representative of a mindset. When we put our mind to something, we can accomplish it. And the only part of that mission that come home is the command module. It's just awe-inspiring to be the curator responsible for this. For 40 years, knowing how important it was to protect the object, it had to be protected by a plexiglass cover. But now we are removing the protective plexiglass. We have a unique opportunity to do this documentation.
The Smithsonian Air and Space Museum gave us incredible access to this object. Our team set out to 3D scan the command module, the exterior and the interior, to create a 3D model that we're delivering online. It's probably the most complex 3D project that our team has undertaken so far. The command module had many sort of hidden nooks and crannies that were really hard to see, and we need to be able to get line of sight to the object. So we used a robotic or a motion control system to basically remotely control cameras and 3D scanners to get around all those different hidden areas that are very inaccessible. The precision of the 3D measurement tools we're using is incredible. We're using laser scanners that capture over 1 million measurement points per second at sub-millimeter accuracy. We also used 6 other 3D capture methods, and we're able to pull all those 3D capture methods into one cohesive 3D model.
So what you're seeing here is some of the really early draft data. This is the raw unprocessed data, and you can see at the center of this scan, it's shooting its beam out in all these different directions, and that generates this cloud of points. And those are three-dimensional measurements that have been made. And so we have to scan from many different locations in and around the object and put these jigsaw puzzle pieces together to make a unified whole.
Our team collected over 7 terabytes of information over a 2-week period. So this is an extraordinary amount of information. The biggest challenge represented was marrying 6 different data sets with different levels of accuracy into one unified 3D model.
We found that through the data, that different stories emerge. Technically, we were aware that there was detailed communications between mission control and the astronauts. Until now, we've had their voices. And then to be able to see that they reacted to these things by actually writing them down on the spacecraft walls, I think is sort of thrilling, because you can actually imagine yourself being in the position of the astronauts. There's a small rectangle with X's on it. We now know that that was sort of an improvised calendar that Mike Collins sort of created. There were markings which humanize certain aspects of those things. What this technology does, it enables us to take the first lunar landings in a concrete form and sort of index it. It's a table of contents, a way to provide a more meaningful access for the young person who just would be thrilled to know what it was like inside of a spacecraft that went to the moon and back.
I'm really inspired and excited about how maybe this 3D scan could inspire future generations to do great things.